We hear the word statistics everywhere, in sports, in the news, and in science. At its core, statistics is just a way to ask big questions about the world and use data to find the answers. It's a tool for seeing patterns and understanding how things change. But before you can analyze any data, you have to know how to ask the right kind of question. The most important term today is the statistical question. This isn't just any question. It's one that you can only answer by collecting data. And the answer you get should show variability. If your question can be answered by looking up a single fact or asking one person, it's not statistical. A statistical question always sets you up to gather many different responses. So what does that word variability really mean? It just means difference. If the answers to your question are all the same, there's no variability, and therefore no statistics involved. Statistics is fundamentally about measuring, summarizing, and explaining why the answers you get are different. For example, why do some students take 5 minutes to get ready, while others take 20 minutes? That difference is variability. Let's see an example of a question that is not statistical. If I ask, what is the favorite color of the student sitting next to me right now? You'll get one specific answer, like blue. Since you only asked one person, there's no variability. The answer is a single piece of information, so you don't need any complex data analysis. Now let's change that question slightly to make it statistical. If I ask, what are the favorite colors of the students in my 6th grade class? I expect to collect data from maybe 25 students, and I'll probably get a mix of answers: red, green, purple, etc. Because those answers will differ, there's high variability. This is a statistical question because collecting all that data is necessary to answer it. Here's a simple 2-part test you can use every time. When you see a question, ask yourself, first, will I need to get information from a large group of things or people? And second, do I expect those pieces of information to be different from each other? If you answer yes to both, you're looking at a statistical question because you are anticipating variability. Let's apply the test to a specific factual question. How tall is the Eiffel Tower? The answer is a fixed single measurement, about 330 meters. No matter how many times you measure it, that number won't change dramatically. Since the answer is a fixed fact, there is no variability in the measurement, and the question is not statistical. Compare that to, how tall are the different skyscrapers in Chicago? If you collect this data, you'll get dozens of different heights. One building might be 500 meters, another might be 300 meters, and so on. The answers will vary. This question requires you to gather and summarize all those different heights, so it is a statistical question. Sometimes questions that seem like they could lead to statistics don't. For example, if I ask one friend, did you eat breakfast today? I'll get one simple yes or no. Since I only have one response, the variability is 0. The question is too narrow, making it non-statistical. To make it statistical, we expand the group. What fraction of students in my school ate breakfast today? Now, I have to collect hundreds of yes or no answers, which is the variable data. Then, I calculate the fraction, say 3 by 4, or 75%. That final fraction summarizes all the variability in the school, making the overall question statistical. A statistical question is nearly always focused on the properties of a group or a population. The question, how old is our teacher, is not statistical. It has one answer. But how old are the people in this room is statistical because you'll get many different ages, 12, 11, 45, etc., depending on who is there. Look for questions that refer to a collection of items, not just one. Sometimes, a statistical question asks for a single number, but that single number is actually a summary of lots of variable data. For example, what is the average number of texts sent by sixth graders per day? The average itself is just one number, but you can't get it without collecting the varying number of texts sent by each sixth grader. The data is variable, so the question is statistical. Here's a question that asks for a summary, but still isn't statistical. What is the highest temperature ever recorded in New York City in July 2024? Even though the question is about temperature, the answer is one historical fact. Once that record is set, it becomes a single, unchanging number. There is no variability to be analyzed, so it's non-statistical. Compare that to, what is the range of monthly high temperatures recorded in New York City over the last 10 years? To answer this, you must look at 120 different high temperatures. Those temperatures vary greatly. The range itself is a number that captures the total amount of that variation. Because you have to collect lots of variable data, this is a statistical question. Remember that variability applies to two main types of data. Numerical data means the answers are numbers, like heights or ages. Categorical data means the answers are categories, like colors or types of movies. If I ask, what is the favorite type of pizza of students in our school? The answers, pepperoni, cheese, veggie, will vary, making it a statistical question. The measurable characteristic that changes is called the variable. If the question is, how many pets does each student in the class have? The variable is the number of pets. You'll get answers like 0, 1, 2, 0, 3, and so on. That collection of different numbers is the variability that makes the question statistical. The group being studied is the population. If the question is, what brand of sneaker do the professional basketball players wear? The population is all professional basketball players. The variability comes from their different choices. A good statistical question clearly defines both the variable and the population. Let's review with a quick fraction example. Is this statistical? Did our class score 80% or higher on the last math test? No. The answer is just yes or no. The final result, whether 80% was met or not, is a single answer for the whole class. It doesn't ask about the individual variations within the class. Now this one. What was the range of math scores for the 5th grade class, which is between 1/2 and 1 whole? Yes, this is statistical. To find the range, you need all the different scores. Say one student scored 50%, which is 1/2, and another scored 100%, which is 1 whole. The scores varied, and calculating the range is a way to summarize that variability. Ultimately, statistics is driven by curiosity about why things aren't always the same. If a question makes you realize, I need to collect many different pieces of data to understand this group, then you've successfully recognized a statistical question. Always remember to look for the group being studied and the variability that is expected.